This is the Average Guy Network, and you have found Cyber Frontiers, show number 38, recorded on July 26th, 2017. Here on Cyber Frontiers, we explore cybersecurity, big data, and the technologies that are shaping the future, all from an academic perspective. I'm your host, Jim Collison, broadcasting live from the AverageGuy.tv studios here in the beautiful Bellevue, Nebraska. And of course, we host the show with world-class show notes, and there's always good ones on this show. You might want to head over and check them out if you're listening live out at the AverageGuy.tv. If you've got questions, comments, or contributions, love for Christian to cover a subject, or you just got a question, you can send it to me via email. Jim at theaverageguy.tv. You can catch Christian. He's just Christian at theaverageguy.tv. Super easy to get a hold of us. Or you can catch us both on Twitter at jcollison. And Christian, what are you using for Twitter these days? I thought maybe I saw a handle change.
I think I'm at Borg Whisperer is what I updated it to.
Borg Whisperer.
Borg Whisperer, yes. One who whispers to Borgs.
That's what I thought I saw. I was like
one would whisper to cats.
Yeah, I like it. If you're whispering to the Borg that way, they don't exist, but that's okay. Well, maybe they do, and we don't know it, but you do.
Correct.
Well, that's good. I want to remind you that the AverageGuy.tv, of course, powered by Maple Grove Partners. Speaking of the Borg, get web hosting, secure, reliable, high-speed hosting from people you know and you trust. Of course, you know that's Christian over there taking a swig. MapleGrovePartners.com. Plan start is inexpensive as $10 a month. Great way to get started, and if you're a podcaster, it's even better because it's optimized for podcasting. So, Christian, thanks for doing all the work that you do to make sure we are lightning fast.
You bet. Okay,
let's dive in. I think we forecasted this 2 weeks ago and said we were going to maybe talk about honeypots. And this is a super interesting subject, at least for me, and I think maybe even an average guy topic. So why don't you introduce it, and then we'll dive in with some on-screen demo stuff.
Yeah, so last week we talked about there was a lot of community interest in seeing how basic honeypots are set up and built. And I think someone asked the question, like, is it feasible to do this from home and do it safely from home? And so I thought it would be cool to show a basic way that pretty much anyone who has the ability to type at a keyboard could play and experiment with the basics of honeypots without getting in danger. So tonight, what we're going to show is essentially a breakdown of how to use some of the common cloud platforms to safely launch, run, and manage your own honeypots, and then do analysis over the data that you get back from interacting with people online.
All right, so simple as that. I think we are going to use an instance. I'm going to use my Azure instance to be able to spin up a Linux server, kind of as the back end. We'll walk through that kind of briefly, and then Christian will share his screen and show us some of the code that we're going to do. We'll share the links to everything that you need to be able to do this in our show notes. So go to theaverageguy.tv/CF038, and you can get a lot of the information that we're going to do there. Christian, where do you want to start?
Yeah, so let's just talk quickly. Azure is a pretty common platform. Amazon AWS is a pretty common platform. So there, and Google Cloud, like those are the big three cloud platforms, right? Almost all of these providers offer like a free tier or a free package. And so like in the case of, I don't know what Azure is specifically, but Amazon has a 1-year free tier for anyone to sign up and register for. So you can spin up what we call a micro EC2 instance. And that'll basically be like a 1 CPU virtual machine that you can run and spin up and do whatever you want with and have a public IP address. So there are plenty of ways to do this experimentation without spending a dime. And cloud platforms are the easy way to do it. The one thing that is important to keep in mind about honeypots, and we'll kind of talk about some of the safeties a little bit more when we get into this, is that it's really important for your honeypot design and your awareness to be such that you make sure you aren't going to cause inadvertent damage to surrounding infrastructure or to the World Wide Web, because you could be potentially in an ethically gray or dubious position to be openly allowing people into a machine to get hacked and then not taking the proper precautions to make sure it doesn't do actual damage. Honeypots are run all the time. They are a hot topic of academic research. In fact, the director for the cybersecurity program at the University of Maryland. His research focus has for decades been in intrusion detection and prevention. And specifically, he was one of the first guys out there playing with honeypots on the network and following some of the original paper trail in academia behind honeypot design, execution, creation, data logs, collecting, and analytics. So a lot of universities, a lot of companies run major honeypots. We've talked a lot in previous shows, maybe some of the earlier shows of Cyber Frontiers, about what the advantages and disadvantages are of a honeypot. And it's really important that you kind of get a sense that it's not just for fun and games. There's a lot of really cool data and valuable insights you can gain about what types of attacks are headed your way, either as a corporation or as an individual or as a network, when you run decoy systems that essentially you don't care about. They're well isolated. They can be easily recreated. They have a lot of great logging. And so you get to learn and kind of watch an attacker passively and then kind of blow them off the instance and prevent them from doing any damage to your real system. So there is an art to it. Things that aren't like Autobots and are actually sophisticated attackers or systems, they will actually be able to detect if they have just logged themselves into a honeypot. The level of sophistication, again, is a kind of like a back and forth thing. So if you get really good at detecting them, the people who design the honeypots get really good at looking like they're just any other ordinary system. What we're going to show you tonight is probably somewhere in the middle. It won't be blatantly obvious that the person has logged into a honeypot, but we'll talk about some of the telltale signs in the implementation that we run tonight that would tip you off that this is a honeypot as opposed to a regular machine. And we'll talk about also some of the ways to mitigate that so you can truly go like kind of full stealth, if that makes sense.
Christian, what's the difference if somebody would be, say, have a piece of hardware locally that they were going to use to do this versus doing it like we're going to do it in the cloud? Are there any differences that need to be taken into consideration?
Not really. You want to apply the same level of protections regardless of where it is, whether it's virtual or physical. I think the one difference is that if you want to experiment with this at home, you're relying on exposing your public IP address, which you might not want to say, hey guys, here's where I am. So that's one thing, especially because a lot of residential IPs probably still don't allow port forwarding and other stuff like that. And so like there's a big advantage to doing it on the cloud, because once you blow away an instance, that IP address essentially gets released and goes back into a pool and then becomes available for someone else in the future. So there's really not, it's very difficult to do any type of person attribution to an IP address when you are in the cloud, as opposed to like a residential IP or something like that. In terms of protecting the infrastructure, it's the exact same thing. So you'll want to set up your monitoring and the design of your honeypot in such a way that you are not posing a danger to the infrastructure around you, or not creating a vector that allows long-term attacking from your box to somewhere else in the world, because then you could be held responsible.
In full disclosure, we set one of these up last night.
Yeah, so we had a bet going about how long it would take for people to actually log in and breach a system. I think it took a couple hours. It was longer than I thought. I think I told Jim after an hour that we'd see data. It took more around the 4 to 6 hour mark from what I remember for stuff to start showing up pretty consistently. But again, the fact that it only takes 4 hours for people to find you on the internet and log into you is pretty awesome. And scary.
It's pretty fast,
but mostly awesome.
We also, when you talked about the Azure instance, they do not, at least at this point on their free plan, was not able to spin up free servers like we're going to use today on their paid plan. I'll show you here the kind of their tiered stack if you want to do it a little more expensive that way. I am, full disclosure, I'm a Microsoft MVP, so I get $150 of credit a month on Azure, and this is the best way I could find to use it. So that's what we're going to do tonight. So, Christian, you want to start with the setup? Is that the best place to go, do you think?
Yeah, so let's basically just show quickly what it looks like to spin up an instance in the cloud. Again, each console, each dashboard is going to look pretty different based on what infrastructure you're using. Like the Azure dashboard looks very different from the Amazon dashboard, which looks very different from the Google dashboard, but essentially they're all doing the same things. You're going to end up doing the same basic actions. It's really just what flavor suits you. Jim is a MVP for Microsoft, so it makes sense he's on Azure. My disclosure is that as an Amazon employee, I'm all about the AWS cloud, so that's going to be my platform of choice, but it's really what you prefer. So of course, we'll advertise and cheerlead for our respective teams, but any platform will do for the purpose of this experiment.
Yeah, and I'm going to, in this case, this is in an instance we are going to use, and so I'm going to create some info that I'm not going to pass along to you. I think, right, last night we did that, and hold on, I got to get a decent password in there. So let's get that. 1 second here. It's not working as well as I want it to. 1 minute here.
Yeah, so you can see all Jim is really having to do is type the name of the instance, put it on an SSD, define the username and password for the box he's going to use. It's going to create a new resource group, drop it in a geographical location, and then he's going to pick his operating system and move right along.
Yeah, I'm actually going to, we have a HoneyPot resource group we're going to add it to. This is where the pricing options kick in, and so you can see they have a DS1, a DS2, and a DS11. You can see the prices. These are the estimated monthly price if you're going to run these virtual servers. So I'm going to choose the smallest stack, single core, 3.5 gig of RAM, 2 disks, some fairly small IOPS, 7 gig available to me on it. There's some other options available. About $50 a month, buck and some change a day if you wanted to go that route. You can see I could do 100 a month or 125 a month. Probably the sweet spot is actually in this $100 a month plan if you think about what you get for that. I'm not going to do much. It's going to give me some storage options, and we're going to leave all of those by default. There was nothing in here that we needed to change. Again, we're setting up an Ubuntu 16.04 instance of this. It's going to give me some information and tell me kind of where it's at, and then I'm gonna purchase that. You can see here then it's actually going to deploy that. It takes a few minutes to deploy anything you want to talk about as it's making its way out there.
Yeah, so pretty much, again, I'll just reiterate, it's going to be the same thing as what you're going to do on any other platform. Jim is going to send me those login credentials offline here momentarily, and then we'll be able to show how you access this instance. I think the key takeaway is just that for the HoneyPots that we're setting up tonight, and most HoneyPots, it's really convenient to set up HoneyPots on Linux. So that's where we're going to be doing a lot of the creation for our HoneyPot software and all the monitoring. There are also Windows HoneyPots, because obviously some exploits and some type of data that you want to monitor is going to be specific to the Windows platform, and some is going to be specific to Linux. But Linux is kind of the origins of where honeypots were born out of and were really first created. So there are a lot of different software options for running honeypots in Linux and Unix environments, and that's the pretty common place where academia chooses to do it. So it's the flavor of choice, not to mention that it's going to be cheaper for you to run a Linux virtual machine in almost any of these cloud environments as opposed to a Windows machine, because when you're spinning up a Windows virtual machine, I think the pricing takes into account the licensing cost for a Windows box just a little bit. So that deployment has succeeded, and now you should see on the screen that essentially this instance has come online. If you look at the bottom right, you'll see the public IP address. That's the IP address that the World Wide Web can see that. So if you were hosting a website or you wanted to talk to this box in some way, you would communicate with that IP address. If you take a look at the options on our left, we see a lot of different information. And Jim, what we're looking for are the firewall definitions that we set up in Azure to set our port forwarding definition. So This is much like if you had to set up a port forward in pfSense or otherwise. By default, when you create one of these virtual machines, it's going to allow port 22. That's for SSH. And the secure shell software that allows you to remotely administer a Linux machine is the sample setup we're going to do tonight for creating a honeypot. So basically, we're going to make that be our insecurity. And you'll see, like, we're making a really dumb security risk in our setup, but we're doing that intentionally. And so we'll talk about that in a bit.
I'm trying to remember where we put that. It's in the rules.
So yeah, you can see the inbound and outbound security rules when you click the effective security rules in Azure.
There we go.
You get a summary when you click the specific one in the platform. You can hit add at the top, and you can see right now we have a SSH port 22 defined. This is the port we're going to eventually use for mimicking a fake server to our clients. So what we want to do is create another port that is random and is in a high port range that's unlikely to be scanned by our attacker, that we can use to administer the box secretly without anyone noticing. Now, what we're doing right now is a perfect example of how someone could be potentially tipped off that this is a honeypot as opposed to a regular machine. A regular machine isn't going to expose more than one port to run SSH, and it's very rare for the box to run SSH on non-port 22 unless you're specifically moving it to a high port for security for port scanning, right? So if an attacker were to become aware of the fact that you were running SSH on two separate ports, they'd probably be pretty suspicious of that. A lot of the more sophisticated and advanced honeypot designs that are built and that we can talk about in future shows, they have a management system that administers the remote system through an internal network, so that essentially there's nothing external visible to the attacker except for the things that you're spoofing externally. So in order to do that, we have to spin up two separate instances and connect them to the same private network and the same VPC, and we're not going to do that here tonight. So we're just giving you an example of how configuration can play a big difference in the quality of the honeypot that you're going to stand up. But for now, we're just going to create a random high port address that's unlikely to be scanned. And tonight's lucky winner will be port 10748, right? So pretty much the operating system for Linux reserves anything under 1024 is system reserved, and anything above 1024 to 655.36 are user-defined ports. So we just pick a random high number port that is hard to scan.
What do you want me to name the rule?
Just call it custom SSH.
Okay. And any source, custom, TCP.
Yep.
You said 10748. Is that what you said?
Yep.
Okay. And then we're going to allow, right?
That's right.
Okay. Oh, I can't put the space in there. 1 second. Okay.
Awesome. So you'll see it's updating and creating the security rule, and then a second it'll show both. But effectively, you've just added a firewall rule directly from the management interface. So you won't have to deal with things like IP tables or other firewall software from Unix, because it's all integrated into the cloud platform. So now that we have these rules set up, we're actually ready to log into this instance. So you're going to open up PuTTY or the SSH terminal of your choice. You're going to input the IP address that was given to you by Azure. You're going to put in a username and a password or a SSH key. And then you're going to log into your box, and that should come up pretty instantaneously. If you see that you're not able to connect to your instance, check your firewall settings and check what IP addresses are allowed. By default on the Azure platform, it allows any public IP address to hit those ports. I'm not sure if that's the same for all other platforms. I think all the default rule settings are different. So now we're going to pivot away from Jim's screen, and we're going to go ahead and share an active view of our SSH terminal here. But let me just get the font blown up really quick. Jim, any other questions about the setup process so far while we get configured over here?
Yeah, no, I think that was pretty simple. I think from my standpoint, I think you want to be well read on just making sure you've got a really good understanding of ports, what's available on those, how you want to do this. In the link we provide, there's some additional information in there, but it is worth, if you haven't, if you don't have a good understanding of TCP and of course some of the port information that comes with it, this is not as a comfortable spot for me. So like Christian, I would rely on you. Last night I can get the infrastructure set up, but I really relied on you to get everything else kind of put together. So that may be the hardest part of all of this.
Sure. So what I'm going to do now is basically jump to the next step. So what we're going to do is we are going to install the HoneyPot management software of our choice. We're going to walk it through on this side, and then we're going to flip over to the instance that we set up last night and pretend that we now have our first data to sit down and analyze. So we're going to use a software called Kippo, K-I-P-P-O. This is a HoneyPot software that basically simulates the file system, simulates running SSH, and basically think of it as like running a dummy virtual machine within your operating system. So it's a way for you to kind of create a specific vulnerability in a specific software or access point and allow the attacker to gain access to this fake instance that really can't do a whole lot, right? So first, we're going to have to go and grab the copy of the software. This is hosted open source on github.com. So github.com/deaster, DESASTER/Kippo. So we need to first basically become sudo so that we can do commands as root and make some changes to this instance. So the first thing we want to do is take a look at our current SSH installation. So this is the SSH of the actual physical management box, and we want to change where our actual SSH is going to be to that dummy port that we created earlier in Azure, so that it's hard for the attacker to know where they need to really log into to gain access to the system. Again, this is probably not the most ideal configuration, but as long as you keep your SSH secure on that higher port, you're not going to have any issues. If you're really paranoid about it, you can also turn off password login to your standard SSH, and then they're trying to break an encryption standard. So at that point, you really don't have to worry. So this file is the file that modifies the SSH configuration. You can find that in Ubuntu at /etc/ssh/sshd_config. And what you'll see in this top definition is a port definition. We're going to go ahead and change that from 22, which is the port we had previously defined, to 10748, which is the new port that we want our attackers to come in on. We're going to go ahead and save and exit that. And then when you're done saving that, because we've already created the firewall rule, you would want to then go ahead and do a system control reload of the process SSH. And what that's going to do is basically reload the configuration that you just edited to move the SSH for this instance to the port 10748. So basically you've taken it off the standard port 22, and in its place, we're going to now put Kippo to run port 22 and make it seem like that's where the actual installation is happening. Now, in order to get Kippo on our box, we need to install an additional software package. In this case, we're going to install SVN. And actually, we're going to use SVN to clone a Git repository, which I know sounds strange, but bear with me. So we are going to do apt-get install SVN. Oh, is it not SVN? I really hope it should be. SVN comes default in this operating system. No, it doesn't. We'll get it eventually. There we go. Apt install subversion. It's the full name in Ubuntu. So we're going to do apt-get install subversion. This is basically just a code repository platform. We're going to use it to clone the code that runs Kippo into our local operating system. So great, we have that installed. So now we can go ahead and check out the code that was on GitHub. And here's the command for that. SVN checkout, and then the name of the URL that I talked about earlier. We'll have that URL in the show notes, so you don't need to worry about it now. Once that is checked out, we notice with the ls command that we created a folder on the operating system called Kippo. So we're going to go ahead and cd to that folder. And now we notice that we have these 4 folders from the GitHub. We're going to switch to trunk. That is the active installation of Kippo. Now we're in the install directory of Kippo. Let's take stock of what we have here. So we have a data folder, we have a HoneyFS folder, we have a Kippo folder, a start and a stop script, some text commands, some utilities, etc. Let's start in the data folder. So what we notice in the data folder is a file called userdb. And this file will define the username and password that we want to be, quote, successful when a user logs in. So in this case, we've defined the password root, or we've defined the user root with the password 123456. Now, the whole idea here is that we're trying to make a simple password that is hard for our, a very simple password that is hard for our attacker to miss. And there have been a lot of studies done on what are the most common passwords in the world by frequency. And it turns out that 123456 takes the cheese for a lot of it. So if you're going to put that really simple password on your root account, that's definitely going to be one that attackers try and go for early on. So you can change this to whatever you want. Again, the harder you make the password, the less likely it is you're going to have people logging into your honeypot when you're first getting it set up. So you could have multiple passwords. You could have one. If you want to define multiple, just do it as many per row as you want, basically. So now we're going to go ahead and look in some of these other folders. Let's take a look at HoneyFS. So this is the fake file system that will be part of what the user sees. So you can see that, you know, there's Etsy and proc, and the configuration software is going to create the rest for us there. But this gives you a sense of how there's a fake file system on top of a real file system. And so now we're going to go to actually take a look at this kippo.config.dist. .dist basically just means it's a distribution file. It's what the default is. So we basically want to make a copy of this original file because it's a configuration file. We want to hold on to the original and just put it to be kippo.cfg is what we actually want. And we're going to go ahead and edit that and take a look at what is in store for the configuration here. So you can see this is the default port it has set up to listen for incoming SSH connections. Because we just changed that port to be 10748, we can change the SSH port here to be 22 because we want to run it on the real one. Here's some other configurables like the host name. You can set what host name the user sees when they log into your box. You can set things like the limit for download files to be stored, what type of file system to use, what types of SSH keys to allow. So there's a lot of configuration options you can set here, and the configuration options are pretty clear when you read the descriptions, so I'm not going to elaborate on them too much here. So once you go ahead and change that port, now we're basically running this instance in a configuration where the fake honeypot is sitting behind port 22, where we're going to have our attacker come in and scan our box and try those different passwords. And our real login to the box is sitting on port 1048. It's using a separate secure login that the attacker isn't going to know. So now that we have Kippo copied and set up, we need just a couple more things. The Kippo software runs on Python. Python comes default with Ubuntu, but there is one package with this version of Python that needs to be set to a specific version. So we're going to go ahead and get some dependencies that are needed by Kippo. These will also be included in the install notes, but you'll see it now reflected on the screen. We're installing the Python developer tools, OpenSSL, Python's OpenSSL, and a couple other tools like Twisted. It looks like it's upset because it can't find everything, but I think we're probably okay here. Let's see what we're missing. apt-get update. Yes, that would be good. Let's do that. There we are. So now we're unpacking and installing those prerequisites. We already installed the subversion earlier to go ahead and get the code. So now the next thing we need to do is create the user that this fake operating system, this fake honeypot is going to run under. We're going to create a user that doesn't have privileges so that it's very hard for any perceived case of having a privileged user cause a problem, right? So we're simulating where they can go to, we're setting a home directory, and we're installing a tool called authbind. This is going to allow us to bypass binding to a port that's considered system reserved. Again, any port that's lower than 1048, Linux by default has a security setting that basically says you cannot set a port in this range without a certain amount of things, being a system user. So as a non-system user, this authbind is allowing us to bypass those permissions to set up a custom configuration for our honeypot. Again, this will be described a little bit more in detail in the docs, but the combination of the documents with following this podcast and the tutorial will allow you to set up the box pretty easily. So now that we've created this user that we're going to run the honeypot as, we're going to go ahead and do a su kippo. This allows our effective user to be kippo instead of root. And we're going to install an additional package that we need called twisted. And this is needed by the kippo software itself. Again, I mentioned earlier, it needs a specific installation of twisted. So first we're going to install Python's package manager. It's called pip. So let's back out of here really quick first. Go ahead and do apt-get install of pip. Or I think it's pip install. Pip install Python pip. There we go. So Python pip is what will be the installer for Ubuntu's package manager and will allow us to install Python's package manager. So it's a little bit convoluted, but nothing too crazy. A lot of these commands are copy paste. We'll also probably create a simple install script if you don't want to have to go through these steps manually. But it's a good thing to get experience with. You maybe pick up a little bit more the more you have to type the commands yourself as opposed to have a script do it for you. So that's never really a bad thing. Once we finish this installation, really the only other steps left are, again, we're going to install this specific version of the twisted library so that kippo has it to use. And once that's done, we're going to be able to go ahead and su kippo. And now that we're in this folder, we'll be able to, let's see where I put that subversion. So one thing we did out of step here is we want to clone the software for kippo as the kippo user so that it can run in the kippo home directory instead of the root home directory. So this will be proper in the instructions in terms of the order of commands, but basically we're just going to go ahead and check out that same source code into kippo's home directory. And if you go back here, you'll see it's the same exact thing. We're going to go into trunk. We're going to go check out that kippo.config, and we're going to set that port to 22. So at this point, we should have everything that we need to start our honeypot. We can start our honeypot with this start.sh command, and you'll see it says kippo config is missing. That's because we need to go ahead and copy over that distribution file that we did earlier to just be kippo.cfg. And once we do that, we can go ahead and run the start command again. And now you'll see couldn't listen to port 22, permission denied. This is because we're currently still running on the actual port 22 that we just moved over because I'm still logged in that same session. But essentially, when you follow all these steps correctly and you log out of your SSH and you log back in through port 1048 and run these commands, this box will come up just fine. So what we're going to do now is pivot to a box that's already running. This is a box that we started last night. And that font may be a little bit small. So let me just go ahead and log back into this again for everyone. Jim, as an average user, what was confusing for you?
Well, from my standpoint, Christian, I would need to spend a lot of time going through the instructions to completely understand what you're doing there. I think for the more technical folks, that probably makes a lot more sense in some of the work that you did. But the document, I read through the document, it lays it out pretty nice. And if you've done some stuff like this before, you should be able to follow along.
Yeah, I mean, it's pretty simple. It requires you pretty much being a little bit versed in the Linux, Unix kind of command shell world, but there's not much difficult stuff going on here. In fact, someone with zero Linux experience could get through all these instructions if they're just taking it one step at a time and paying really close attention to detail.
Yeah, the instructions aren't complicated. I mean, they're pretty straightforward, but there might be a few new commands or just some things you need to get familiar with. Just kind of work it through slow.
So we're gonna now bring up, here's the instance that we started last night. It's the same deal here. And let's go ahead and again, become root user and then become the Kippo user like we talked about. So now if we take a look at our folder, we see our friend the Kippo, and we're gonna switch to its install directory. Great. So now what we can see is, so this is already started and running, and what we did is we created a log folder. And let's go ahead and take a look at that log file. So this is basically a copy of the log file for all of the attempts that have been made on this fake SSH server. So what we can see here are pretty much all the IP addresses, what type of protocols they tried to use to connect to the box. And what you'll notice as we go down here is we can observe what the usernames and passwords were that they tried. So we can see some log entries here, like root trying auth login attempt, and the login attempt was root with the password WUBAO, WUBAO. So having some basic skills in processing these logs, we can start to find a lot of interesting statistics about the data. And this is how professional honeypot designers do this at scale to find out bigger things, like the most common passwords in the world are 1234556, or the most commonly attacked country is this, and they are most commonly attacked from this country, right? So let's go ahead and learn some basic Linux commands that you probably may already know. We're going to first just cat this temp file of the log that we created. This is basically just reading all of that text file into our terminal. Now we want to look for specific phrases within that file. So in this case, we're looking for all lines that have the word login attempt in them. This will filter our results to just show the lines that have the login attempt recorded in the log file. Now you can see the highlighted line that says login attempt, and we can see all the cases where it was administrator / whatever. But this still looks kind of messy because it's flowing over the screen and it's kind of hard to read. So now we're going to pipe this to a command called cut. Cut basically looks at the line and it uses a delimiter, and it says, tell me what field you want me to read, and I'll read that specific field. So we're going to count the number, the delimiter here are spaces. So we can count how many fields that are defined until the phrase that we want to see. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it's the 9th field. I could be off by 1, but we're going to go ahead and do that and define space as the delimiter. And now we can see that in the results, we just cut down the result file to the specific usernames and passwords that were attempted. So there's a lot of cool things we can do with this data. First, let's go ahead and sort our results. Okay, so now we can see basically these were all the login attempts, the username and passwords that were tried on this box. We can see that over the period of the 24 hours that we've been running it with the count command, that there were 489 attempts on this box in total. We could also now see how many unique attempts there were by first calling the unique command and then calling the count command, wc-l. And you'll see that of the 485 attempts that we had, 261 were unique, meaning a unique username or password combination was attempted. You can then group by these and do some counting and all sorts of other Linux commands to figure out kind of what are the frequencies of these, what are the interesting data points. We can just do some human analysis tonight by looking at this result file. We can see that admin and administrator are a pretty common username to guess, along with root and super and test. Those are like the common usernames. You can see that they may have also fingerprinted us because they're trying the username ubnt, which is short for Ubuntu. So maybe they knew that we were running on an Ubuntu operating system and that user may have been there. And then we can see all of our common password combinations. So we see 1, 2, 3, 4, 5, 6. We see with a lot of different combinations. We see some swear words. We see all sorts of pretty fun stuff. So this is one type of analysis that you might want to run. If we go back to that log file, though, we see that there's more than just username and passwords. We see that there are also IP addresses. And so we could take a look at every line that says new connection : references a specific IP address. So let's go ahead and modify our command to instead grep for the phrase new connection. And we might have to change what field we cut on. Okay, so now we see these are all the IP addresses. Now we're going to filter on, they're going to be 7. We'll just take a guess. Ooh, I was one too far here. There we go. So here are all the unique IP addresses that were tried. And what we can see again is that these have port numbers too. And the port numbers are random, so we don't really care about the port numbers that we're sourced from. We just care about the actual public IP address. So we're going to go ahead and filter this out again with another cut command on the first field, and now our delimiter will be the colon function. And now you can see we just have IP addresses showing, right? So let's go ahead and this is, again, all the same exact log file. We're looking at very different ways of analyzing it, kind of just average homebrew sort of stuff. So let's go ahead and sort those results. And we can see some interesting things right away without doing anything further. We see that a lot of the attempts were tried from the same IP address. We see that a lot of the attempts were tried from the same subnet. So 59, 45, 175, 67, pretty popular, right? If we go ahead and again call the word count command, we'll see that there were 151 attempts from 151 public IP addresses, and the number of unique IP addresses that attacked our box was 44. So another thing you might want to know is, well, where are the people from around the world trying to attack and log into this instance from? So we're not going to show this script tonight, but a common script that you might want to run is a IP address lookup for every IP that you got a result for. And so here's basically an example of a website that lets you look up what the IP address is. There's scripts and other places where you can do this in bulk, but we just looked up one IP address. And what a surprise, we see that China is the origin IP address that tried to attack this instance. It looks like the internet service provider is China Telecom Liaoning. And so you can see where on the map it approximately falls on. You can also interestingly see some user comments for this field. And if the user wrote, the person is essentially trying to SSH into me. So it looks like we're not the only ones who have had a SSH attack from this IP address. So we're going to go ahead and close that. So this just gives you a lot of different like basic average guy stuff that you can try with simple log files to analyze and see what's going on in the honeypot. And this is kind of the basic setup phase, is figuring out What is the service that you want to have? How do you want to make it artificially vulnerable? And how do you want to track and monitor that vulnerability? Now, what I showed you earlier was just a log file of all things that went on with SSH. But if we go into the data folder, I believe, we'll see a text file called lastlog.txt. And if we go ahead and take a look at that last log, this is a list from Kippo of all the successful logins that happened on this box. So these are all the IP addresses and all of the basically user sessions and times where a user gained entry into our system. And so this means that they successfully guessed the login root with the password 123456 and gained entry. When they gained entry, however, they logged into a dummy SSH. They could only run a very limited set of commands. They couldn't really do much. And so it probably didn't take very long for the attacker in this particular case to realize that they had logged into a honeypot, and then they promptly probably left. So this is a very basic honeypot. We've just showed you the basic concepts here. The next step, and what could potentially be a part 2 series for us on Cyber Frontiers, is going to the next level, which is you essentially run an artificial system that is just as powerful as the real system, and they can't tell the difference. What this allows you to do is observe the malware or the attack pattern that the attacker is going to install on your box, so you can see exactly what forensic artifacts and behavior are left on the machine. This is really valuable because you can get a sense for how attackers are spreading and creating malware and what their objective is in trying to hack or attack your box. The important thing to note with this is that when you switch from a dummy honeypot to a fully functioning honeypot, your risk goes up and you have to be much more careful. So now that they basically have, quote, the power to do anything as the root user, they may use your box to be part of a botnet. They may use your box to go and attack another host, and you could be held responsible. So in order to mitigate that, there are a lot of things that everyday ordinary people do. For example, some honeypot designs might, and the design choices are up to you, right? Some folks might say, we give the attacker 5 minutes of free reign to do whatever they want on this box. And after 5 minutes, the box is automatically deleted and recreated from the last checkpoint before the breach happened. Then that data is basically exfiltrated and collected, and we can study a lot of things that we couldn't see in the demo that we did tonight. For example, we can see all the commands that they ran. We can see how long it took them to run those commands. Did they have any typos? Were they successful in installing it? What things did they delete or remove out of the system, right? So there's just a lot of operational and behavioral artifacts about what the attacker is doing on the box that we can start to collect when they have fully enabled systems. That might not be the only approach, right? So a very common approach is basically give them 5 or 10 minutes, let them do whatever they want, collect that data and all the logs, and then wipe the box and reset it to its last known good state. Another technique might be you want to get a text message when someone logs into your box so that you can kind of walk over there and see what's going on, right? So you want to maybe set up some alerting and monitoring. But these are all basically additional pieces that get set up after you have the basics of the honeypot set up and you've learned kind of the basics of how to configure a honeypot and have good honeypot design. One of the really important aspects of any honeypot creation or project is ideally after you've done, you've completed learning just the basics of setting up and configuring one, you want to come up with a hypothesis and you really want to say, what is it that I specifically want to study about the attacker? What is it that I specifically want to learn about how they're taking advantage of my box? It's really important to come up with the hypothesis before you start doing data collection and running your honeypot, because then you'll be able to take a quantitative and analytical approach to answering questions that you might have. So like if I have the hypothesis that I think the most common password that attackers guess is 123456, if I set that hypothesis before I start running my honeypot and data, I can't change my experiment, I can't change my parameters, and I can't introduce bias into my data set that allows me to artificially arrive at that conclusion. That may not be what you're interested in. You might want to know what is the most geographic intense region for me? Where's the diversity of commands? What is the most common malware? So you have to ask your own questions. If you look at some of the academic research papers around honeypots, you'll see that all sorts of really fascinating questions have been asked that even get into the levels of psychology and forensic behavior of attackers. We'll post in our show notes the original kind of seminal work in academia on honeypot design called A Journey with Burford, I believe. And this was written back in the mid 90s. So like it gives you some context for how old honeypot design is and yet how incredibly relevant it is to security in today's light. But hopefully this overview and this demo and tutorial gives you a sense for how you can securely run and create your own honeypots from home without any risk, and well, with risk that you're controlling and not causing real risk to you or anyone else, and how you can do that for free and learn something along the way.
Free or maybe a little cost, depending upon what platforms you're using, right?
Yeah, pretty much. So
yeah, go ahead and turn your screen back on, Christian,
yeah,
if you
right.
would, and so we can see. Actually, that if you blow that up full screen on your computer, you can see all the code pretty easily. That's cool. That's that's live data. That's data that we collected over the last 24 hours. Christian and I set these up last night. One of the reasons we delayed was so that we could get that out to you, but fairly interesting.
Yeah, it's one of these things that I think a lot of people don't realize just how easy it is to do at home. I think a lot of people think you need robust infrastructure or a lot of protections in place, and it's really just if you take the time to put in the commonplace design decisions at the front end of what you're doing, it prevents you from getting in a dangerous territory very quickly. So just a couple common sense smart decisions at the beginning can allow you to have a lot of fun with data exploration and learning. A lot of the things that detect, like a lot of people ask me, how do spam filters know what spam is relevant to me so well? There are honeypots that are called, there are literally spam honeypots that particularly filter, and they're just designed as open mail relays. So they're actually trying to collect and they're trying to basically entice people to send spam to their mail servers so they know exactly what is spam and what isn't spam. So like honeypots have a lot of real world value to enterprise, whether it's your spam filter, whether it's updating your antivirus engine, your signature files. Like there's a lot of cases where nothing beats getting out in front of the attacker like giving them fake stuff to have them show their cards first so that you can build the defense for the systems that do matter.
Yeah, and then it's the back and forth, right?
Exactly, right.
Discovery, trying to hide, discover again, try to hide, pull out, shut off, put your left foot in, put your left foot out, shake it all about, right? So it is one of those things. I imagine now at this point, so if this got compromised and you said to me, hey, Jim, we need to shut that down, in any of these platforms, I could come out and I could show this, but it's just really simple. You just say delete and system goes away. We did that last night, actually, the first test. You guys probably saw early on. We called the second test the one he demoed off of, and then third test was tonight. First test we set up, and then you're like, oh, blow it away. And we just deleted it, took it down. And after the show here, I'll take these instances down. And or if I wanted to save them, I could just stop them. And we could stop them basically in place and then spin them back up when we needed them.
Yep, absolutely.
Cool. Anything else? We're right at just under an hour. Anything else you want to cover there?
No, that's the quick 1 hour demo on how to get a honeypot set up for the average guy. So
all right, there you go. And of course, if you got questions, Christian's a great guy. Don't send them to me, to be honest. I'll be like, send them to Christian. Christian at theaverageguy.tv will get you there. If you want to track him, if you want to get him on Twitter, my new favorite Twitter handle, Borg Whisperer.
Borg
Whisperer. Yeah. You can find me, Jay Collison. Hey, don't forget Cyber Frontiers and Home Gadget Geeks, both powered by Maple Grove Partners. You get great web hosting out there. If you want to get to all the information, track that down. If you need it, plans as little as $10. MapleGrovePartners.com. All right, with that, we'll call it a Cyber Frontiers. If you are in the chat room, stay around for a few minutes. We won't spend too much time in the show, but We will have, there'll be maybe some other side questions that you have coming out live, a little bonus content for the live listeners. Christian will be back in a couple weeks, and maybe a part 2 on this, or maybe something different. Watch Twitter, and we'll let you know what's going on. With that, we'll say goodnight, everybody.
Good night.